This lecture is part of PHA 205. In this lecture, the topic will be about presenting data. So after we have discussed the role of statistics in research, and then we introduced the concept of the different types of data, we actually made a point stating that statistics is used for two reasons, for estimation and for inferential. And we're still part of the estimation process, whereby we have mentioned that estimation is basically doing two things to data, summarizing the data and presenting the data. This lecture will be about presenting data, and since data is of two kinds, categorical and numerical, we will talk about how to present data for these two different types of data. However, first, here are general guidelines for creation of tables and graphs and plots. Every table or graph or plot should have a title which should be a self-explanatory title explaining what is the graph about, the who, the where, the when, and the why. The graph or table or plot should be utilitarian. It should be neat, it should be orderly, and it doesn't have to look very pretty, it just have to look professional. In other words, if the graph is taken out of the context, if a graph is taken out of the paper or presentation, someone reading the graph should be able to understand all the components of the graph, whether the color codes or shading codes, everything has to be explained part of the table or the graph. So let's start. As you already know, there are two types of data. There's the categorical and numerical data. We will start with the categorical data. For categorical data, there are two ways where we can display the data. First, using tables, and second, using graphs. For tables, it's very simple. You just have to list the the categories of the variable, and then list the frequency and the percentages, which we kind of has discussed part of the summarizing the table, summarizing the data. But also sometimes we also add the cumulative frequency and the cumulative percent. So here we have an example where for variable gender, the data points for variable gender or the levels are males and females. These are the two options for gender. So you will list males, females, and then you will list total. You put the frequency, so 95 of the 200 were males, 105 were females. You will report the percentages. You may also report the cumulative percentage, which is basically you add up the frequency till you reach the 200. And same thing for the percentage, cumulative percentage. So for education, for example, the participant in this study were either had a BS degree, a Master's of Public Health degree, or a Master's of Science degree. The frequencies are such that 158 for the BS, 25 for the Masters of Public Health, and 17 for the Masters of Science. They add up to 100. The percentages are 79.0, 12.5, 8.5. They add up to 100. Then the cumulative frequency, you start with 158, which is exactly the same number here. For the second row, you add up the 25, so that will get you to 183. And then you add up the 17, and that will get you to 200. For cumulative percentage, you start up with 79. You add the 12.5, you get 91.5, and then you add the 8.5, you get 100 as a cumulative percentage. When you're reporting percentages and the frequencies, make sure that you're consistent in terms of the decimal point. So you will notice I'm reporting one decimal point, so I have to report one decimal point for all of them. So if I want to be more accurate here, I have to add a decimal point. Okay? So very simple, straightforward for categorical data. Notice the title, frequency table for gender, and program enrolled in for 200 students enrolled in the Faculty of Health Science for the summer of 2004. So the data, by reading the title, you can figure out everything about this data. As for the graphical display, there are two major types of graphs, the bar chart with pie chart. The bar chart, basically all you're doing is you're putting the categories on the y-axis and on the x-axis. On the horizontal axis you put the categories, and on the y-axis the the vertical axis, you will put either the frequencies or the percentages. You have those two options. One thing to be careful of when you're doing a bar chart is not to make the columns colliding. That is the recommendation, so that you don't give a false impression of a continuous process at the x-axis. These are categories, categorical data, and not numerical data. However, for aesthetic, it's better than the width of the bars be of equal size. Okay, so I'm not making one bar very fat and the other one very skinny. Okay, here's an example from the literature of a bar chart. If you look at the y-axis, you have number of patients, so this is called a frequency bar chart. If we had percentage, it would be a percentage bar chart. You will notice the title, which is quite explicative. By reading the title, you will understand what this bar chart is and where is it coming from and what year and what is looking at. And so we have two options for hematuria, either no or yes, and the height of the bar is relevant to the frequencies in every group. Here's another one. In this bar chart, things are a bit more complicated because not only you're showing the years 1998, 99, all the way to 2004. However, within every year, you're showing the type of problems reported to Microsoft. So it's either a bug in pink, security holes in grayish, and a backdoor in blue. And looking at the y-axis, we have numbers and not percentages, so these are frequencies. And therefore, you can read this bar chart that is representing two variables. One is the types of security problem and the academic, not the calendar year. Okay, and by looking at what is happening over time, you can notice a trend, for example, where the problems kind of in 2004 became much less frequent. And you can look at every type of problem where sometimes they go up and sometimes they drop and then they go up, etc. Obviously, a problem with this graph is that it doesn't have a title. It requires a title. However, via an annotation, we were able to tell what the color stands for. Another example of a bar chart is this one, but also that one. This is a sideways bar chart. Same idea as a regular bar chart, but it's done sideways. And by reading the title, you can figure out what this bar chart is about. So this is the US drug shortages from 2001 to 2010. So again, you have the years, the calendar years from 2001 to 2010. And then you're looking at the shortages for each year represented by the number of the new reports between January 1 to December 31, meaning يعني in 2001 there were 120 drugs in shortage. The number of drugs in shortage in the US dropped all the way down to in 2006, but then they picked up and went back again, increasing in numbers in 2010. We are reporting the frequency here. However, if you move to the side chart, you will notice that what we have on the x-axis this time is the percentages and the reasons for the sterile injectable drug shortage in 2010. So they picked one type of a shortage, which is sterile injection drug, in 1 year, 2010, and then they're showing you what the reasons behind the shortage, starting from the most leading reason, which is due to product quality issues, followed by the least important or frequent reason. Okay, and again you have the source and you have annotations. They're showing you the percentages, so you kind of be able to understand everything by just reading these graphs. Another type of a graph that is utilized for categorical data is pie charts. Pie chart basically are just a pie that is divided in relation to the percentage of the outcome. So here we're looking at a pie chart and we have the blue that is showing no relapse. The frequency of people that did not relapse is 31, representing 21%. Then you have the orange for those that had a relapse more than a year after a year of treatment. The frequency is 44 and the percentage is 27. And then the yellow is those that relapsed within a year of treatment, and the number is 85, the percentage is 52. Two things about this graph. First, it's lacking the title, so we have no idea what we're looking at. Relapse about what? Who are these patients? What year was it? What is it about them? Why are we looking at this data? So there is a lot of information missing on purpose, because I wanted to show to you that if you retrieve, or if there's information missing, you won't be able to understand everything about the graph. The other thing is, with the pie chart specifically, if you do not represent the percentages, it will be very hard for the reader to understand or to be able to detect what are the percentages on their own. So with the pie chart, always make sure to report the percentages. Here's another example of a pie chart, and it's divided between non-Hispanic blacks, non-Hispanic whites, the Asian or Pacific Islanders, the Native Americans, and the Hispanic. If you want to understand what this pie chart is about, you have to read the title. It says Pie Chart for the Distribution of Tuberculosis. Uh, it's reproduced with permission from Figure 1 in Doling, Return of Tuberculosis Screening and Preventive Therapy, and it's coming from the American Pharmaceutical Practice, I guess. It's a journal, and that article is published in 1991. Again, notice that without the percentages, it becomes very hard for us to figure out what percent, for example, the Hispanic represent out of the total pie. Okay. One more example. This is a pie chart showing the native speakers of English. So we can tell that out of the title. And you can tell that the majority are from the US, followed by UK, then Canada, then Australia, and others. However, you don't know exactly what is the percentage because you're not provided with the percentages. The title is there. It's a title that is a good title, but probably it's missing the year. Here's another pie chart with a lot of colors, and it's made in 3D, and it's showing the percentages. The only thing missing in this one probably is the title. For categorical data, there are other ways that you can present your data, maybe. I'm making it simple. I'm just sticking to tables, bar chart, and pie charts. Now we're going to move to talking about numerical data, and again in numerical data we're going to keep it very simple. We're going to talk about tables, histograms, and boxplot. Let's start with the frequency table. For numerical data, you may remember that numerical data is basically not made of categories. However, we did mention that you can turn numerical data into categorical data, which we will do when you want to summarize it into a frequency table. So for example, here you have systolic blood pressure, which obviously is numerical data. And what the author of this table did is that they they created categories or intervals. So they decided that everybody between 90 and 109 will go in this grouping, 110 to 129 in that grouping, and so on and so forth till the last grouping. So that's the first thing. So this, we call these the class interval. However, you should be aware of the class boundaries. And basically is the class boundary is where the 109 and the 110 split. Okay, so think about a patient that has a blood pressure of 109.4. So 109.4, do we put that person in the first category or in the second category? There are different ways to do it, different ways. One of the ways is to find the midpoint between 109 and 110. So for example, 109.5, anything below it will go in the first category, anything above it will go in the second category. However, more recent tables or authors have been using the boundary um, as the beginning of the class interval of the second one. What I mean by that, anything that has 109 point something will still go in the first one. So 109.8, 109.9, 109.99, we will still put that person in this category. Again, let's look at this category, for example. It goes from 150 all the way to 169. So if you have 152, you will put that person here. 155, you will put that person here. 167, you will put that person here. 169.8, you will put that person here. 170, that's where you start putting the person in the second category. Okay? So you make up your categories. You make sure your categories start low enough to include the lowest value and high enough to include the highest value. And then you will put your frequencies. So you will count how many people are in this category. So that's your frequencies. And you will do your percentage. Okay. Again, the concept of decimal point works here as well. Okay. So though your numerical data in fact is still numerical, but you are summarizing it to put it in a frequency table by categorizing it. Okay. Um, Personally, I would not have included the last interval here because there's no one in that interval. So honestly, there is no need for that last interval. I would not have included it. Same thing about what we said earlier. You need a title that clearly explains what we're looking for. So the title is Frequency Table for Systolic Blood Pressure of Non-Smokers. So okay, now we know that we're looking at non-smokers, but we don't know where they are coming from and like why are we looking at them. Okay, so here you have a general guidelines on how to create your frequency tables. You can read them on your own. It's very simple. Then we're going to move into examples. So over here you have an example of a table. The 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 um, the title is Frequency Table for Heart Rate Variation to Deep Breathing, and the table is split into two parts, one for men and one for women, which is perfectly fine. You have your categories for each. Then you have your count, our frequency. It's exactly the same thing for each, followed by the cumulative count and the cumulative count for each. We discussed what the cumulative is. Then the percentage for each and the cumulative percentage for each. Okay, so looking at the categories, notice how the first category is less than or equal to 20, followed by 21 to 30. ما في overlap in the category. Okay, followed by 31 to 40. يعني ما عندي 30 21 to 30 واللي وراها بتجي 30 to 40. If you have that, then 30 is appearing in both. Okay, another thing is you're not skipping a category. So 31 to 40, the next one is 41 to 50. We don't skip 51 to 60. You have to have all the categories in order. Okay, and as I mentioned, you start low enough to include everybody at the bottom and high enough to include everybody in the top. Notice how the last category is greater than 90, مش greater than or equal, because the 90 is included in this category right there. Okay? And basically everything else is just the way we discussed. So we have 18 individual with a heart rate variation below or equal to 20. You have, for example, if you look at this 28 value right here, you have 28 individual with heart rate variation between 51 and 60. And when I say between 51 and 60 هون عم بحكي على men because I'm looking at the men. Okay, for cumulative account, you're just adding up the 18 to 22, you get 40. Then you add 40, whatever you got, the 40 to the 45, you get 85, and you add up till you reach the last value, which is 221, meaning that you actually have 221 men. And if you want to know how many women you have, you look at the cumulative count right at the end. You have 206 women. And same idea for the percentages and the cumulative percentages. Obviously, the cumulative percentage has to add up to 100. Okay, now comes the histogram. Now, basically, a histogram is just your frequency table, but you turned it into a graph. Okay, so here's the systolic blood pressure, the first data I showed you. On your x-axis, your horizontal axis, you're going to put your class interval, and on your y-axis, you're going to put your frequencies or percentages depending إذا بدكم تعملوا frequency histogram ولا percentage histogram. هلا, the author of this histogram particular used the 0.5 as the class boundary. أما نحنا قلنا we would not use that. So if I was doing that graph, I would put 90, 110, 130, 150, 170, and 190. And hopefully my way, it would be easier to read. Okay, so that's the first thing. The next thing about a histogram is that since the x-axis is actually a numerical variable and not a categorical variable, then the width of every bar in a histogram, that width is a meaningful width, okay? It's representing the difference between the lowest boundary and the upper boundary. Also, the histograms, the bars of the histogram are collided to one another because there is a continuum of data. Not to mention that the title and the annotation, so you have to tell us what the x-axis stands for and what the y-axis stands for, okay? So we're going to look more on histograms. So here are general guidelines on how to do histograms. Here's one more histogram, okay? So again, you can see that this is a frequency histogram. We're representing the frequencies and not the percentages. On the x-axis, you have the score of something called the SMAF. Okay, and actually it's a changes in the SMAF. If you want to know what the SMAF, I have it here for you. You can read it. And basically, we're looking at the changes. Okay, هلا notice إنه كل البارز are of equal width. So the bars are of equal width, and that width is meaningful, and you have all the bars that are colliding with one another, with the except of this empty slot, and the reason is because there's no one here. Okay. Another thing that is neat about the histogram is that it shows you the distribution. So looking at this histogram, you can see that this histogram has a tail that is dragging on the positive side, meaning that it's skewed to the right or positively skewed. So if you remember, when that happens, large numbers pull the mean more than they pull the median. So if you were to calculate the mean and the mean will be larger than the median. The mode is right there at 0. Okay. More example of histograms. Here's another nice example of histogram. Okay. Except that ما في عنا title, ما في legends. We have no idea what we're looking at. However, if I want to ask you, like if I give you this and I ask you, do you think the histogram is skewed or symmetrical? Anything that is kind of like symmetrical, we call it symmetrical. Unless it's very heavily skewed, we will not say it's skewed, we'll say it's symmetrical. Okay, so moving along, here's another one again. And also, ما في عنا title to explain it, but we kind of like see the salaries here, and we see the numbers of employees there. So we kind of have an idea that we're looking at the salary distribution of employees going from 0 to 10, 10 to 11, 11 to 21, etc., all the way up. Okay, and overall the distribution seems similar. The only problem with this one is the last interval, which is 88 plus. So even 88 plus could go all the way up to 200 or 500 or 600. The author of this graph decided to cut it and graphically show as if it is as of equal width to all the others, which is not correct. Okay, one thing also about histograms, you have to make sure that the your your y-axis starts at the 0. Okay, you cannot start your y-axis at 500, otherwise you will give a false or distorted histogram. The last thing I want to show you is the box plot, and the box plot is a very interesting plot that has a lot of advantages. A box plot basically is made of a box, okay, which is right there. The square is called the box. You have the sticks that are going up and down. These are called the whiskers. And then you have the cuts. These are the boundaries, the limits of the whiskers. And you may have outliers, or you may have extreme values. And I'm going to explain how it works, okay? So let me move to paint. And basically what you're going to do is, in your data, you're going to represent you already remember what Q1 stands for. So you're going to represent your three. Let's say I'm going to draw it as not on the y-axis like the one I showed you, but on the x-axis. So it's going to be on the side. So you find your Q1, you put your Q1, then you find your Q2, you put your Q2, then you find your Q3, you put it, and that creates your box. Okay? So now once that you created your box, the width of your box, okay? If you remember, this is the difference between Q3 and Q1, and this is your IQR, okay? Except we don't call it IQR when we're doing a box plot, we call it something else. We call it the H spread, okay? Alright, so you're going to take this X spread and you're going to multiply it by 1.5. So the H is now multiplied by 1.5, okay? And whatever that value is, so I have a distance of that, so 1.5 probably up here and 1.5 probably down there. Hala, when you come to draw your whiskers, this is what's going to happen. Your lower whisker starts from the lower value, okay, and you start going down all the way to the boundary, unless the minimum occurs first. If the minimum occurs first, then you stop at the minimum, okay? And same thing for the maximum. You're going to take your Q3 and you're going to go up, and you are allowed to go all the way up to the limit that you defined, unless you reach your maximum first. If you reach your maximum first, you stop right there, okay? You're going to stop there. Hello. In the event where you went all the way down to the limit that you're allowed to go to, but still there are values, then you stop. You don't go any further. You draw your boundary. And then any value that is below that boundary has to be represented either with a bubble, okay, or with a star, okay? A bubble is representative of a number that is occurring beyond the the boundary, however within another distance of 1 point h, okay? So the other 1 point h, you're right to get a bubble, however anything beyond the second 1 point h, you have to represent it using a star. And this is true for the lower limit and the upper limit, okay? So let's go back to the lecture and see if I can show you the description. So here's the description. The graph, a box plot, we need to compute the median, which is Q2. You need to compute Q1 and Q3. Remember, these three lines will represent your box. Your interquartile range, which was the difference between Q3 and Q1, yani the width of your box, is called an H spread. This H spread is multiplied by 1.5. Then the lower fence is is your Q1 and you travel down 1.5h. Your upper fence is your Q3 and you travel up 1.5h. If the minimum is larger than the lower fence, yani it occurs before the lower fence, then you stop the whiskers at the minimum. However, if the minimum is less than the lower fence, then you stop at the lower fence. You denote any lower value with either a bubble or a star if more than 3h. Same idea for the upper side. Okay, so again here I have examples of box plots. So none of these of box plots are on extreme values or outliers except for this one right here. Uh, More examples. So you can see that a box plot can be shown on the y-axis, while on the x-axis, the height of the box if it's up, or the height or the width of it if it's on the sideway, and the difference between Q1 and Q3 is meaningful. However, how large you make it has no meaning. It's up to you. It's arbitrary. Okay. This slide kind of like repeat everything I said. Okay, so you have your Q1 median Q3 shown. You have your lower fence. You have your upper fence, and then you can see that here this value is represented with a bubble because it falls within the next 1.5h, whereas this value is represented with a star because it's falling within more the second 1.5h. And I'm finishing up with showing you if you have a nice bell-shaped normal distribution, the box plot of that distribution will be very symmetrical. Okay, so let me go back to my drawing. Again, a box plot can show you the shape of the distribution. So if you have a box plot that looks like a box plot that looks like this, then this is a skewed distribution. Obviously, you have this side sticking out, so it's skewed to the right or positively skewed. Okay, right. What I'm going to do next is we're going to do an example of a box plot, and hopefully things will be clearer. So I'm showing you a data set, and let us count how many values we have. So it's 1, 2, 3, and I'm just going to do the counting all the way down. I have 19 observation. First thing we need to do is find Q1, Q2, Q3. The easiest thing to do is to find Q2. I have 19 observation plus 1. That's 20 divided by 2. That's the 10th observation. So right there, that's my 10th observation. I'm going to give it a color. Then my data is split into 9 below it and 9 above it. Let's find Q1. So 9 observation plus 1 is 10 divided by 2 is the 5th observation. So right there, that's your Q1. And same thing for the second part, 1, 2, 3, 4, 5. This is your Q3. Okay, so Q1 is at 68, Q2 is 71, and Q3 is at 88. Let's draw our box. So first thing I'm going to do is I'm going to draw an X so that I can put my values. You will excuse my drawing. Starting as low as 0 maybe, and maybe I could put a 50 here, put 100 here, put 150 here, and right on the 200. Okay, so that's a 200. If you remember, my Q1 can, let's see it again, my Q1 can 68, then 71, then 88. Okay, so 68, if I want to draw my somewhere, maybe 68 is here, maybe 71 is here, and 88 is here. So I just drew my box. I'm very happy. Okay, now next thing I have to do is calculate my h. Remember, the h is equal to the IQR, yani Q3 minus Q1. So that's 88 minus 68, that's 20. Then you have to multiply it by 1.5. So 1.5h is 30. Yani if I take 88 and I add to it 30, I reach 88 plus 30 is 118. Okay, this is the maximum value you can reach with your whisker. And same thing, if I take 68 and I take from it 30, I will reach 38. So this is the lowest value I can go to. Okay, right. If you look downwards, I have a value below 38. I do have a value below 38. So I'm going to extend my lower whisker all the way down to 38, and I'm going to stop my whisker. Okay, so I take and I extend all the way down to, let's say this is right there, 38, and I stop. Okay, right. Let's go back to the data. I have a value below 38, which is 15. But is it occurring within another 1.5h, or is it occurring within more than 1.5h? So 38, let's take from it another 30. That will get me to 8. مظبوط? Okay. However, 15 occurred before the 8, and therefore I will represent the 15 with a bubble. So right at the 15, somewhere here, okay, I will put a bubble representing the 15. Now let's do it on the other side. On the other side, and I have to go all the way up to 118. Do I have values beyond 118? Yes, I do, and they will this one, that one, and this one. So my upper whisker is going to go to 118, and I'm going to stop it at 118. Okay, so I extend all the way to 118, and I stop at 118. And let's look at the values that are occurring beyond 118. If I add another 30 to 118, another 30 and 1.5h, another one, I will reach 148. اوكي هلا لاحظوا قبل ما اوصل ل 138 148 عندي 142. So high will be a bubble وكل شيء beyond 148 will be a star. So the 190 will be a star and the 240 will be a star. So لكن عندي bubble على 142 عندي star على 190 وعندي star على 240. Okay, so على 142 somewhere here I have a bubble. Okay, على 160 and 190 so على 142 كانت عفوا على 190 عندي star وعلى 240 عندي star. So I go back to my drawing. على 190 بدي احط star هلا. Okay, وعلى 240 بدي احط star. I can't لأنه I should have drawn it better than this, but you would understand على القليلة إنه I should have another star here. Okay, so basically this is the idea behind drawing a box plot, and hopefully if you have any further question we can address them during the lecture.